Welcome to Mysterious Universe. Today, we're going to take you on a journey unlike any other, far beyond the stars you see at night and deep into the cosmic unknown. The universe is vast, ancient, and beautiful, but above all, it is deeply mysterious. Despite centuries of scientific progress, we've barely scratched the surface of its secrets. And it is in those secrets, those cosmic puzzles without clear answers, that we find not only our greatest challenges, but also our deepest sense of wonder. In this episode, we're diving into the 10 most mysterious things in the universe, phenomena so strange, so baffling, that they challenge everything we thought we knew about physics, astronomy, and our place in the cosmos. From invisible matter to unbreakable physical limits, from galaxies that shouldn't exist to the ghostly echoes of cosmic history. These are not just questions for scientists, they are invitations to explore the unknown. Why is most of the universe made of something we can't even see? What causes the most powerful explosions ever recorded? Could the laws of physics be different in another universe entirely? These questions aren't science fiction, they're science, pushing us to the very edge of knowledge and daring us to leap further. So if you've ever looked up at the night sky and felt both amazed and overwhelmed, you're in the right place. We're going to break it all down, one mystery at a time. And we're going to do it together, with curiosity, with awe, and with the spirit of exploration that defines who we are. If you love science, space, and the thrill of discovering what lies beyond, hit that like button, subscribe to Mysterious Universe, and ring the bell so you never miss an episode. Now, let's explore the 10 greatest cosmic mysteries that still keep scientists awake at night. Dark matter. We know it's there, we just don't know what it is. Dark matter makes up approximately 27% of the universe, yet it neither emits, absorbs, nor reflects light. We can't see it directly, but we know it exists because of its gravitational effects on visible matter, especially in galaxies. Without dark matter, galaxies would simply fly apart, their stars moving too quickly to be held together by the gravity of ordinary matter alone. What is this invisible substance? Is it composed of undiscovered particles? Could it be something even more exotic, like a modification to gravity itself? Despite decades of research and billion-dollar detectors buried underground or launched into space, we still have no definitive answer. Yet, without dark matter, our models of the cosmos simply don't work. It is the invisible glue holding the universe together, and it may be the key to understanding everything else. Dark energy. If dark matter holds the universe together, dark energy is what's tearing it apart. In 1998, astronomers made a shocking discovery. The expansion of the universe isn't slowing down, it's speeding up. Some unknown force, dubbed dark energy, appears to be pushing galaxies apart at an ever-increasing rate. Today, we believe dark energy accounts for nearly 70% of the energy content of the universe, making it even more prevalent than dark matter. But what is it? A property of space itself? A new field? A sign that our understanding of gravity is incomplete? Its existence reshapes our cosmic timeline and suggests that the universe will end not in a crunch, but a cold, dark, endless stretch known as the Big Freeze. The matter-antimatter asymmetry. The Big Bang should have created equal amounts of matter and antimatter, yet we're here, and the universe seems to be dominated by matter. Where did all the antimatter go? This imbalance is one of the most important unanswered questions in physics. When matter and antimatter meet, they annihilate each other, releasing energy. So why didn't the universe self-destruct in a blaze of mutual annihilation? Some theories suggest subtle differences in the behavior of particles and antiparticles, known as CP violation, may hold the answer. But our current understanding doesn't fully explain the magnitude of the imbalance. Understanding this mystery could tell us why anything exists at all. Black holes. We've imaged their shadows and mapped their gravitational waves, but black holes remain among the most mind-bending objects in the universe. Formed from the collapse of massive stars, black holes warp space and time in extreme ways. Their gravity is so intense that nothing, not even light, can escape their grasp. At their core lies a singularity, a point where our known laws of physics break down entirely. How do black holes interact with quantum mechanics? Can information really be lost in a black hole? Or does it find some strange way to escape? These questions touch on the deepest foundations of physics, and they're still far from resolved. Fast radio bursts, FRBs. Imagine a signal from across the cosmos, lasting just milliseconds, yet releasing more energy than our sun emits in days. That's a fast radio burst. First discovered in 2007. FRBs are extremely powerful radio signals from distant galaxies. Some are one-offs, others repeat. But their origin remains unknown. Are they produced by exotic neutron stars? Colliding black holes? Or, as some speculate, even advanced alien technology? While scientists are closing in on potential sources, every new FRB discovered raises more questions than it answers. The nature of time. We all experience time as a flowing river, moving from past to future. But in physics, time is much more complex and mysterious. Einstein showed us that time is relative, affected by motion and gravity. But why does time have a direction at all? Why can we remember the past but not the future? At the microscopic level, the laws of physics don't seem to care which direction time flows. The arrow of time may be deeply connected to entropy, the tendency of systems to become more disordered. But a full understanding of time's nature remains elusive, and unlocking it could revolutionize everything from cosmology to quantum computing. The Fermi paradox. If the universe is so vast and old, where is everyone? This is the essence of the Fermi paradox. With hundreds of billions of stars in our galaxy alone, and trillions of galaxies in the universe, it seems statistically likely that intelligent life should exist elsewhere. And yet, we've found no definitive evidence, no signals, no probes, no visitors. Are we alone? Is intelligent life incredibly rare? Or is it possible that civilizations self-destruct before they can explore the stars? Some theories suggest that we may be in a cosmic quarantine, or that advanced life is so different from us, we simply can't recognize it. Quantum entanglement. Dubbed spooky action at a distance. By Einstein, quantum entanglement is a phenomenon where two particles become linked, so that the state of one instantly affects the other, regardless of the distance between them. This isn't just theory, it's been demonstrated in labs repeatedly. But it defies classical logic and challenges our understanding of locality and causality. How can information seemingly travel faster than light? Entanglement lies at the heart of quantum computing and may one day revolutionize communication. But the deeper mechanisms behind it remain one of the most confounding puzzles in physics. The Hubble tension. How fast is the universe expanding? You'd think this would be a simple question, but astronomers have hit a roadblock. When we measure the expansion rate, called the Hubble constant, using observations of the early universe, via the cosmic microwave background, we get one value. But when we measure it using nearby galaxies and supernovae, we get a different, faster rate. This disagreement, known as the Hubble tension, could be due to systematic errors, or it might be a hint of new physics. Something fundamental could be missing from our cosmological models. And solving this tension could reshape our understanding of space, time, and the early universe. The multiverse. Finally, we come to perhaps the boldest idea of all. The possibility that our universe is just one of many. According to some theories in cosmology and quantum mechanics, other universes may exist beyond our own, each with different physical laws. Particles, or even dimensions. These parallel universes could explain some of the fine-tuned properties of our own, why, for example, the constants of nature seem perfectly suited to support life. But if these other universes are truly separate from ours, how could we ever observe or test for them? The multiverse remains a controversial but tantalizing possibility, one that forces us to rethink the very definition of reality. Conclusion. As we've seen, the universe is not just a place, it's a puzzle. A vast, unfolding mystery where every answer leads to new questions. Dark matter, dark energy, the nature of time. The possibility of other worlds. These are not fringe topics or theoretical exercises. They are frontiers. They are where science meets imagination, where data collides with wonder. And though we may not yet have all the answers, the act of searching itself is what drives discovery. It's what took us from firelight to starlight. From wondering about the sky to walking on the moon. These 10 mysteries are more than topics for textbooks. They are calls to curiosity. They remind us that science is not about knowing everything. It's about embracing the unknown, asking better questions, and daring to explore what lies beyond the horizon of current understanding. So if your mind is buzzing with awe and your heart is stirred with wonder, consider this your invitation to keep learning, keep asking, and keep looking up. Subscribe to Mysterious Universe for more explorations of science's biggest questions, and join us as we continue to probe the mysteries that make the cosmos not just vast, but beautiful, surprising, and endlessly fascinating.